Geometry, Chapter 3, Section 2, Properties of Parallel Lines. Today, on this lesson, we're going to try to prove theorems about parallel lines and use those properties to find angle measurements. Okay, so moving on to the very first thing. What is the difference about angles pairs that form when a transversal intersects parallel lines? So here's what we know. Here's the postulate. Corresponding angle postulate. It says this: if a transversal intersects two parallel lines, then the corresponding angles are congruent. So in this example, angle 1 is congruent with angle 5, because again, the corresponding angles. Angle 6 is congruent with angle 2. Angle 4 is congruent with 8. And angle 3 is congruent with 7. So, problem 1, identifying the congruent angles. Which angles measure 55? Well, if angle 1 equals 55, we know angle 7 must equal 55 because of why? Because they're corresponding angles. What do we know about angle 2? Well, it's a vertical angle, so that's got to be 55 as well. And if 2 is 55, 6, because it is corresponding, is also 55, or because it's vertical with angle 7. Okay, so now it says, is there another way to justify angle 6 equals 55? We just did that. Using linear pairs, find the measure of angle 4. Well, linear pairs tell us two angles have to equal 180 if they create a line. So the measure of angle 2 plus the measure of angle 4 must equal 180. The measure of angle 2 is 55. The measure of angle 4 right now we do not know. So we're going to subtract 55 to each side. So the measure of angle 4 must be 125. So which other angles are congruent to measure of angle 4? Well, angle 4 has a vertical angle with 1, so it's parallel, congruent. And angle 4 is corresponding with angle 8, so it's congruent. And angle 5 is congruent because of vertical angles with 8. Okay? Any questions on that? Rewind it if you need to. Make sure you understand the concepts. I know we're kind of buzzing through it pretty quick. Okay. Well, you can use the corresponding angle postulate to prove other angle relationships. Okay. We can prove, which we just did earlier, alternating interior angles are congruent as well. So angle 4 must be congruent with 6. And angle 5 must be congruent with angle 3. So alternate interior angles of parallel lines are congruent. All right, here's the other theorem, same side interior angle theorems. If the transversal intersects two parallel lines, then the same side interior angles are supplementary. We know angle 4 plus angle 5 must equal 180. We know 6 and 3 must equal 180. Okay, so let's just prove that theorem, okay? Alternate interior angle theorems. We know L and M are parallel. Prove that angle 4 and 6 are congruent. Well, L and M are parallel. That's given. We know angle 2 is congruent with angle 6 because corresponding angles are congruent. We know 4 is congruent with 2 because of vertical angles. So we can say 4 is congruent with 6 with the transitive property of equality, or I should say congruency. So just read through that. And again, the hint to the left says the symbol angle means angle. The symbol angle with an S means angles. You can use symbols in place of words as shortcuts and proofs. Okay? So let's find angle relationships. Given angle A and B are parallel, prove that 1 and 8 are supplementary. Okay. Well, here's what we know. We know angle A and B, lines A and B are parallel. That was given. We know angle 1 and 5 are congruent based on corresponding angles. We know measure of angle 1 is the same as the measure of angle 5, because that's congruent angles have equal measure. Angle 5 and angle 8 are a linear pair. That's just the definition of a linear pair. Okay. 5 and 8 are supplementary. Well, angles that form a linear pair are supplementary. So the measure of angle 5 plus 8 equals 180. That's the definition of a supplementary angle. So now we can substitute measure of angle 1 plus measure of angle 8 for the substitution property. So hence we can prove 1 and 8 are supplementary. Okay? Theorem 3.3, alternate exterior angles. If the transversal line intersects two parallel lines, then alternate exterior angles are congruent as well. So 7 is congruent to 1, and 2 is congruent to 8. We can use based on vertical angles of this angle and this angle and corresponding angles of this and this, we can prove that pretty easily. All right, so if you know the measure of one angle formed by two parallel lines in the transversal, you can use theorems and postulates to find the measures of all the other angles. So the question in number 1 is, what are the measures of angle 3 and 4? All right, so everything's parallel. So angle 3 is alternate interior angle to 105, so we know the measure of angle 3 must be 105. All right. Sorry about that. Cut that out. We know the measure of angle 4 and 105 because they're same side interior angles off of the transversal Q. We know they must be supplementary, so we can say the measure of angle 4 plus 105 has to equal 180. So subtract 105 to each side, measure of angle 4 must equal 75. Okay, use the diagram in problem 3. Find the measure of each angle. Justify each answer. All right. Angle 1 and angle, so how can we prove what angle 1 is? Well, we know corresponding angles are congruent, so that must be 105. All right, we know alternating interior angles are congruent, so that must be 105. So angle 1 and 8, measure of angle 1 plus the measure of angle 8 must be equal to 180 because they're supplementary, so subtract the measure of angle 8, which we said was 105 to each side. So the measure of angle 1 must be 75. B, the measure of angle 5, well, it's corresponding with 105 here, so the measure of angle 5 has got to be 105. Measure of angle 6, well, we have alternating interior angles, so the measure of angle 6 must be 105. And the measure of angle 7, well, 105 and 7 are vertical angles, so it must be 105. Okay? Okay, moving on to the next one. You can combine theorems and postulates with your knowledge of algebra to find angle measures. What is the measure of angle y? So let's look at this one real quick. So we know this angle and this big angle are same side interiors off of the transversal I'm going to highlight in blue. So we know the sum of those three angles must be 180. So we can say the measure of angle y plus 40 plus 80 equals 180. So we can say the measure of angle y plus 120 equals 180. So we can subtract 120 each side and say measure of angle y equals 60. So we got that one pretty easily. Okay, so the next question says this. In the figure at the right, what is the value of x? Well, what I highlight in yellow are the transversals. Okay, and what I highlight in blue are the parallel lines. So we know same side interior angles must be equal. So I can say, well, that color just darked it out. I can say 2x, I can say 2x plus x minus 12 must equal 180. So I can say 2x plus x minus 12 equals 180. Sum like terms, so I'm going to get 3x minus 12 equals 180. Add 12 to each side. So I'm going to get 3x equals 192. Divide everything by 3. I get x equals 64. Okay, so part A was the value of x, so there's my answer to A. B is the value of y. So I can do the same thing. I can say 3y plus y plus 20 equals 180. Sum like terms, so I'm going to get 4y plus 20 equals 180. Subtract 20 to each side, so I'm going to get 4y equals 160. Divide each side by 4, y equals 40. So that's part B. So the next one says find the value of every measure. So 2x is the same as 2 times 64. That would be 128. So this one is 128. This one's 3y. So 3y is equal to 3 times 40, which would be 120. 120. This one's 12x minus 12. So that'd be 64 minus 12, which would be 52. So that one's 52. And this one's y plus 20. Y plus 20 is the same as 40 plus 20. So it's 60. All right, we went fairly quick, but if you need to review it, you can. It's here for you to use at your disposal. All right, good luck. And if you have any questions, don't forget to contact me and let me know.